Hello everyone. This video I'm going to talk about the first the first functional programming language, which is LISP. I repeat, the first functional programming language is LISP. Okay, and LISP is introduced in the year of 1960. So when you see the genealogy of all the programming languages, you will find Lisp place as the third high level language. The third high level language. Then what is the first high level language? The first high level language is Fortran. And the second high level language is COBOL. The third high level language is Lisp. I'm not going to give all the list of the languages because you already know the genealogy of all the programming languages from the unit 1. So there we learned about the genealogy of these languages. So now time came to talk about Lisp. So I am bringing into your notice that Lisp is the third high level language. Okay, right now. So Lisp was, I just told you that Lisp was first functional programming language, and it is very important point as far as Lisp is concerned. When I told about or when I said about Lisp is the first functional programming language, so all the dialects of Lisp are not only functional programming language. So there is a point to justify my statement. With the exception of first version, all Lisp dialects include imperative language features. That means imperative language features are what? Data types, control statements, abstractions. These are what actually imperative language features. There are many features as we discussed. You can see even the video of unit 1 for the better clarity what are features of imperative languages. So by the time, uh, I mean, by the progress of Lisp, from the first version to the last version of Lisp, if you see that only the first version is pure functional programming languages. And later all the versions of Lisp are included with the imperative language features. And what Lisp is a programming language, as I told. And what are the data types Lisp will support or Lisp will take? So that are two data types, which are atoms and list. Data types are atoms and list. Now the structure is what? Arranging the atoms into one structured manner, which is linked list. We will be arranging the instructions. Now let's see that I have given some instruction in the Lisp language. So half the way that memory will be get created or half the way it will get operated, that is what the structure. Fine. So now this structure is what? Linked list. Now let's see. Let's understand what is atom, what is list. These are not types in the sense that imperative have types. When I told you that this is data type, don't misinterpret that. We'll write in the program specifying it is a atom, correct? But it is not the type in the sense that imperative have types. But what is this? How, in which sense these are what data type? Now understand. The original Lisp was a typeless language. Will not specify to which data type it belongs. Atoms are either symbols in the form of identifiers or numeric literals. What are atoms? We will not specify atom in the program because as it is typeless language. And then what is atom? Atom is what? It may be a symbol or it may be an identifier or it may be a numerical literal. What we are writing into the Lisp interpreter. Yes, Lisp uses interpreter. I repeat, Lisp uses interpreter for the execution purpose. List elements are pairs, where the first part is the data of the element, which is a pointer to either an atom or a nested list. The second part of pair can be a pointer to an atom, a pointer to another element or nil. So I'm sure that you can understand this definition with the example. Now, now look at this. This is what simple list. This is what simple list. Lists are specified in Lisp by delimiting their elements with parentheses. The elements of simple list are restricted to atoms. As in as in this instruction, these are what atoms. Atom is what? Just now we had a discussion about atom. Atom is either it is a identifier or it is a letter or it is a numerical literal we were to see, right? So these are what atoms. And you can also find the other thing in the down of the statement, and this is what list we used to say. if i uh, if I wanted to tell what is nested list is something that will write a b c and d e f g list inside the other list is called as nested list. Now it is called as a nested list, okay, and it is called as a list. This is also a list with atoms and sublist, okay. This is what list of atoms. This is list with atoms and sublist. This is what list we used to say. This is what list with atoms, list and nested list. Did you understand? Now here the first element is an atom, the second is the sublist which is bc. When you see this one, the first is an atom, the second bc is an list, d is again atom, the fourth sublist is what? EFG, which has as its second element sublist FG. In a Lisp implementation, a list is usually stored as linked list structure in which each node has two pointers, one to reference the data of the node and the other to form the linked list. A list is referenced by a pointer to its first element. The internal representation of about two lists are given here. So this is what internal representation of a list. That list can have atoms, that list can have atom sublist, the list can have nested list. Whatever it may be, we will be showing the internal representation of all this list using a linked list, right? Now look at this. This is what the first Lisp interpreter. So in the last video we were discussed, the first video of this unit we were discussed about how it will be evaluated. Now I wrote here plus 5 7. What do you mean of this? Now this is treated as a function. Plus is a function that takes two or more numeric parameters. Now the above expression evaluates to 12. The function will return a value which is 12. If it is 3, 4, 7, 6, it is an invalid expression in imperative. I repeat, it is an invalid expression in imperative. ఎందుకు why means plus is an operator in imperative, but plus is an function in functional programming language. I don't want you to confuse in this concept. I am talking imperative and I am talking functional. Imperative plus is sense as an operator. In functional, plus is sense as an function. So when it is a function, it is not having any invalidity in the statement. Why? Because this function is going to apply on these parameters, and once after result is done with this, then let us see 3 plus 4 becomes 7. Now again this function is going to call recursively, 7 plus 7 becomes 14. Again function will be applied on this parameter. Now 14 plus 6 becomes 20. The answer is 20 for this statement. So the point is what? Lisp is such a programming language where the first atom is called as an function. The next are called as an parameters. So this is the way how we will be evaluating using list interpreter. So this is about Lisp programming language. So you should be very clear with the concept of these concepts. What is exactly Lisp and what data types, what list and atom basically defines, and the internal representation of the list, and how the expressions will get evaluated in terms of functions. So these are what the important concepts what you have to keep in mind as far as Lisp programming language is concerned. So thank you all. We will be going to discuss continuity in the next video. Thank you all.